In the previous class, we have learned the transit time effect, and we can neglect the transit time effect if the length of transmission line is much less than the operating wavelength. One can therefore model a transmission line by a lump elements by dividing the transmission line into small section such that over each subsection the transit time effect is negligible. It is therefore appropriate to define circuit parameter for unit length of transmission line. The circuit element, the circuit element the circuit element are not located at a particular point at a particular point or location location of the line, but the circuit elements are distributed all along its length, are distributed all along its length. Since so transmission line can be modeled as a distributed network in which we find R. R is the resistance. R is the resistance. Since conductor is not ideal, so there is some loss in the conductor, and this loss is represented by R. Loss in conductor. Loss in conductor is represented by R. Then in transmission line, we have two conductor, one conductor and another conductors. Transmission line is two conductor system separated by a dielectric media. This will form a capacitance C. This will form capacitance, and the medium in which the transmission line is present is not ideal. There is some leakage in the medium, and that leakage is represented by G, transconductance of transmission line. So leakage is represented by Z, and we know that magnetic field link with current will produce in inductance. So all these four parameters R, L, C are defined per unit length. These four parameters are defined per unit length. Per unit length. This is also defined per unit length. Per unit length, and G is also defined per unit length, and L is also defined per unit length. So for delta x length, if we consider a very small length of transmission line, that is delta x, for delta x length, the impedance is R delta x, C delta x, G delta x, and L delta x for a small section of transmission line. For a small section of transmission line. For a small section of transmission line. Now all the parameters R, L, C and G are defined per unit length. If you are trying to calculate this value for any length, then multiply with the value of length. So we can model transmission line using all these values, that means C, G, R, L. This is this is L and R. If we look at this circuit arrangement, then these four parameters are distributed throughout the length of the transmission line. So transmission line is called distributed network. So transmission line is called distributed network. So these four parameters are distributed throughout the length of transmission line. Hence transmission line is called distributed network. For a small section of length delta x, transmission line, equivalent circuit of transmission line can be represented in this manner. In first case, this L and C kept like this, and G and C kept are in parallel, and here L and R are in parallel. Then we form a pi network. This is a simple pi network. We divide this impedance and capacitance both sides. So this is equal to G by 2 delta x, and this is equal to L by 2 delta x. This is nothing but the representations of this distributed network. This distributed network. Another representation is the T network. This is simple T, and again this will form a pi. These are the different network which we used to represent the transmission line.